Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and be welcome to Chemical Process Engineer Diary. In this series, I share with you my daily activities as a chemical process engineer. And to talk about what happened tomorrow, I will focus on three main topics here. But if you have any questions, let me know in the chat. Currently, I am transmitting or I am streaming in Instagram at my left side and also in the YouTube channel. So the three main topics for today will be related to pressure drop issue or calculation or evaluation because I am facing some kind of trouble because of that in a utility in a facility that I support, and I will talk to you a little bit about it and how what I did to find what was the issue and etc. And the other topic is related to mentoring. Yesterday I had a set of meetings with my mentees, and this is part of my mentoring program in Process Booster Mentoring. And today I will have another set of meeting. And in this meeting with sellers from South Africa, we talked about pumps. So I will share with you a little bit about the subject. And with the Hafiz from Singapore, we talk about career development. So I will bring to you a little bit about the subject, and I have until 8 a.m. here in Brazil, but I try to let these sessions around 30 minutes. Okay, guys? So if you have any question, just let me know in the chat. So starting with the pressure drop issue, what happened is that I have compression station and receive gas from our supplier, and between the battery limits at our gas station and after the measurement units, we have a little skid to do the measurement of this gas. We identified that we have 7 bar, around 7 to 7.5 bar of pressure drop in the battery limit, and that is an issue for us because we are planning to add a dehydration system, and this kind of system perform better when the operation pressure is higher. And just to give you some references, I am receiving my gas at the battery limit at 16.5 bar G, and with the pressure drop, currently pressure drop, it's going down to around 9 bar G, and to perform well a dehydration system according to the suppliers, I need to have at a minimum 13-14 bar G. So it is an issue, and as it is an issue related to process engineering, I am responsible to evaluate that and verify why we are having this kind of issue in the battery limit and how to solve that. And always take in mind that when you identify a problem, you must at the same time look for options or look for solving that. Okay, so that is our mission when we are in a job. And there was many guesses about what was happening. I don't have the PNID to share with you, but just to make you understand, we have the battery limit, and the battery limit is the part of the process where we shift responsibilities from one player to another. So imagine that we have a fence, and at the left side of the fence, it is the pipeline from the customer. And when the pipeline gets to the fence, to the right side is my unit process, or my process unit. So the battery limit is the fence that informs us that at the left side I am not responsible for any kind of maintenance. I am not responsible for the design of the pipeline. And at the right side as it is inside my process unit. I am responsible for the maintenance, for the design, for the verifications, and etc. So what I recommend you if you are working in a plan design, every time that you have a battery limit with the customer, when you need to receive feeds, a feed, or when you most when you need to feed to receive a feed, or when you need to supply a product, add some minimum instrumentation to the battery limits to verify the pressure, the temperature, and in some cases you need to verify the flow. Flow, sometimes it's not required, but if you are talking about custody transfer, if we are talking about fee, most often we have some kind of measurement, flow measurement or volume measurement, but at least pressure and temperature, it's very important to have in the battery limits, because with that you know the references to your process. Sometimes I have seen that more than one time. The customer specify I work in a project that the customer needed to receive hydrogen at 11 bar G at the battery limit. So always remember that your customer received the product at the battery limit of the unit process. And we were developing the process, and it was a estimate and reformer, and the technology for the licensor, the battery limit was the outlet of the PSA. So they were a PSA, pressure control, and for them the battery limit was there. But between the battery limit of the PSA that was inside my plant, my process plant, and the battery limit with the supplier, there was around 500 meters. So there was a 500 meters. And what previous or business or previous engineer did was inform to the supplier of the hydrogen units the 11 bar G at the PSA. And what happens when we do that, between the PSA and the battery limit with the customer, there was 500 meters, and there is a pressure drop, because it is the way that happens in the real life. So there is the pressure drop, and to the customer, I would not be able to deliver the 11 bar G, because wrong assumptions during the conceptual design, and it was going through the project until we verified that during the execution we had this kind of issue. Sometimes you can increase the pressure to compensate, sometimes it is not possible, so it is a contract issue, and you must avoid that at any cost. So always remember or be aware that you need to be aware that because that means money, okay? And if your company is losing money because you did a wrong design, it's not good for your career, it's not good for your reputation. So just to continue, I have the battery limits, I have isolation valve, I have a strainer, I have a vessel separator, and I have my metering system that consists of a control valve. I have Coriolis, that is a mass flow measurement, and I have the temperature transmitter and the pressure transmitter. So in my battery limits, I have the indications of pressure, and after the measurement, after the Coriolis, I have another tap for measuring the pressure of the system. So between these 2 points, there was a pressure drop of 7.5 bar or around about that. And there was many guessing, as I told you, and people was trying to justify this pressure drop based thinking that the demister of the vessel separator could be dirty, or it could be clogged in some way, or if the strainer was dirty also, because if you have a strainer that is dirty in your operations, it will increase the pressure drop. The demister is a kind of device that is responsible for coalescing any liquid that you have in the gas, and that there are small spaces between the plates, so depending on the kind of the design of the demister. So the first guess was to appoint to these two fittings in the process, but I needed to go deeper on that. And what I verified is that for the conceptual of this unit, the pressure drop was not a big issue, because the plant was supposed to operate around 12 bar G. So receiving with 17 and pressure drop, doing the pressure drop to 12 bar G would not be an issue. But now that we are needed to add a dehydration system, we verify that 14 bar G is the minimum. So now this pressure drop is an issue. And what I verified first, the operations verified in the field that the strainer was clean, and it is not possible to open the separation vessel, so we didn't do anything about that. But I went to the control valve data sheet and verified that the conditions for designing the data sheet was that the control valve should give 5 bar G pressure drop. So that was a design issue already. To have the maximum flow, the medium flow, the minimum, in the normal flow, the chemical engineer consider a pressure drop of 5 bar G in the valve, and that means that the CV calculated is short if I do the opposite. If I decrease the pressure drop, we need a higher orifice area, and because of that the CV increases. Okay, guys, so this was the point for the first point. I found the one part of the pressure drop explanation. The other part is that when we add a Coriolis to our system for measurement, usually the Coriolis has a higher pressure drop if we compare that for a plate, orifice plate, for instance. Orifice plate, we talk about millimeters of water column in terms of pressure drop, but Coriolis not. And I went to the supplier catalog and verified that per standard design of them, they consider 1.7 bar of pressure drop in the instrument. So if we have 5 plus 1.7 in rounding, because the pipelines, if we have 5 plus 2, we have 7, and that explain why we have so big pressure drop in the system. And now, how I can solve that? And before talking about that, when we are specifying a pressure Coriolis, it's very, very important that you ask it for, when you are doing the quotation, you receive some material to do technical evaluation. It's very, very important that you ask for the curve of flow and pressure drop in the device, because in this kind of situation you will know exactly with accurate value what are the expected pressure drop for the maximum flow, the expected pressure drop for the average and for the minimum. And that is very, very important, because when we are, if we are talking about a gas that goes for a compressor, once you decrease the pressure, we, especially if we are talking about volumetric compressor, if we decrease the pressure, the gas will expand. But it means that for the volumetric pressure, for the volumetric compressor, we will have the same amount of volume, but the mass inside the compressor will be less, and that will lead for less efficiency. You will produce less product because you will have less mass. Okay, guys. So this is a point very, very important when we are talking about plane design. And to solve that, what I did, I got the manufacturer software, and I verified the new conditions that I want to. And instead of having 5 bar G of pressure drop in the control valve, I need to have 0.2, and I verify if it would be possible to use the same valve for the new service. Instead of buying a totally new control valve, I am interested on preserving at the least the external, the casing, and reduce the schedule, because the schedule is very, very important to me in this case. So I went to the software, I verified the catalog of the supplier, and usually a same series of control valves can have different size of CV of the valve. So for the original design, it was around 15 CV needed, and with the new conditions, I need a control valve with 50 or 50 CV. And I verified that in the same series, it's possible to have different CVs for the same valve body. And I addressed the question to the supplier to verify if it is possible only by the internals and do changes and etc. Based on the Coriolis, I am not able to do anything about that because it's an instrument that is already installed. But with this, instead of having 5 bar G, more 5 bar G of pressure, I will answer you, Assad, just a minute. Instead of having 5, I will have 0.2, and that will increase my pressure from 9 to 13, and depending on the pressure that I receive in my battery limits, I will be able to run my dehydration system without any problem. So this is an example of activities that the chemical process engineer do in the daily life, okay? And it is related to operations, it is related to plan design, and sometimes we have small changes in the process that it's not as the same of the design big units, but the philosophy or the methodology to doing the documentation is the same, and it doesn't matter if you are talking about big industrial facility or if you are talking about small changes. So Assad asked me which software for the catalog search. So it depends on the valve supplier, and in this case I having Emerson Fisher control valve. So I looked for the Fisher management sizing. I think the name of the software is this one. It's very common that the control valve suppliers have some kind of software available for the customers. So although if you are a student, sometimes it is free to download and verify, sometimes not. But if your company has the control valve from the supplier, for sure, if you talk with the vendor, they will give you the access for this kind of software, okay? And I know that I most often I use the Samsung control valve sizing because to do especially to do preliminary control valve sizing. But in this case, as I have installed in the field the Amazon, I must use the Amazon software to get a reliable response. And there are others. There are another supplier. I forgot about the name, but this is it, guys. In my Instagram cell phone, it's alerting me about the low battery. Okay, guys. So if it shut down, is because the battery. So I have some comments here in the YouTube chat. Let me see. Hello from Greece, Mr. Costa. I am a chemical engineer and new to the oil and gas industry. How would you advise a guy who is new to the industry? I will talk a little bit about that. And I have a question. I have a message from Akshay Patil, one of my students. Thanks a lot for being here, Akshay. What is the procedure? Validate the modified design considerations. That's a nice question because one of the challenges to let the documentation up to date in a facility is to have some kind of management of changes procedure. And that is very important because with the management of procedure of changes, or MOC in some cases, the companies name that, you have a procedure, and the procedure will tell you first you need to identify the issue. After that, you need to verify the options, verify if the modification suggested, if that add any kind of hazards to the process, and you need to have someone. Usually we have a multidisciplinary, or we have a senior engineer verifying if the modifications it's okay or not. Rishav and Assad, I'm doing also this live session in YouTube. Okay, so if you have having issues with the Instagram, I recommend you to take a look in YouTube because my cell phone in Instagram is lower battery. So, and in the YouTube I using the headset. Okay, so guys, the best place is the YouTube. Sorry for that. I'm new to this multiple streaming. Okay, so the MOC is very, very important, and usually we will have a checklist so that will guarantee that you will follow all the steps that are needed to do the modification of changes. Yeah, management of changes. Okay, and I had another question here that was about the career, and that is very interesting because yesterday, as I mentioned in the beginning of this live session, I had a series of meetings with my mentees, and with one of them, Rishabh from Singapore, we talk about career development. And you see how my mentoring program is not only to help people learn how to use the Aspen High Seas, it is how to use it to talk about career development and issues related to the industry. So what I recommend him to do, and I recommend to you also, if you are interested in join the industry, oil and gas or any industry. First thing is to do or to create a LinkedIn profile. In the current world, I believe that it's very, very important that you have a digital presence. And to do a LinkedIn profile is very easy. You go to the LinkedIn, you need to add your email, and there are the procedures there that you must follow to do your account or your profile. And one thing that I recommend here and that I believe that is very important is adding a photo that is look for the eyes. I mean, I have seen people asking me, especially suppliers that doesn't have a photo, a personal photo of the person, asking for supplying products for me. How can I trust someone that doesn't show his face or her face? Okay, so when we are in social media, we are supposed to interact with people. And if you are a person behind the profile, and if you have good intentions, it's for sure that you share your face. Okay. I have seen some questions related to my mentoring program. Guys, I will open new seats only on May. Okay, so if you are in my Telegram channel in process, you will be alert. If you if you join my newsletter, you will be informed also. And so the first part is to do the profile, add a nice photo showing your face, and with that you start, you do your first step for having a linked profile. The second thing is to add to your profile information related to what kind of job you want to join. For instance, when you participate in one of my master classes, I share what the industry I share a series of open process engineering open position and the description and also the requirements. So if you have the requirements that are asked in this job position, you should add to your LinkedIn profile, because when the recruiter do some search in the LinkedIn, the algorithm, it will address to what you add to your profile. Okay, so it help LinkedIn recommend you for any kind of open position. And another thing is that if you want to work with plan design, you should identify the main companies or every company in your country that offer this kind of job, because this way you can find people on LinkedIn that works with these companies, and it's never when you ask for connection, ask for a job for anyone. And that is my point of view. Okay, I receive a lot of questions related to job, and first thing first, I live in Brazil, so the person don't read my profile, and they are from far away from Brazil, and they ask for a job. And if I have many chemical process engineers in Brazil, why should I consider the person that I even know for a job? So it's a good sense, okay, guys? But you should connect with people and show interest about what they are sharing, what they are posting, because this way you will starting building a connection, and when you have a connection with someone, will be easier to get recommendations, it will be easier to receive a response from your questions, and it will be easier to you reach more people in the social media. So this is very, very basic that I recommend you. And another tip, and I will not get into details, but not to let you know, we have a phrase here in Brazil that says something like this: if you are not seen, you are not remembered, or you are not reminded. I don't know if it's this quote is this way in other countries. Okay, so my recommendation for my students is that they do at least one post per week. And imagine that you are new in the LinkedIn, you do a profile, you add the key information in your profile, and you start and connect with people, and I recommend you when you ask for connection to add a personal message saying something nice or something. For instance, you have seen a post. I have seen your post, and I am preparing myself to work in this industry. I would like to connect with you. Something like this, okay? So you send the connections. This is a better way to start a relationship, in my point of view, guys. Okay, this is my point of view. Other people can have other point of view. And when you starting doing posts weekly, the connections that you made will receive this kind of post in their feed, and if they got interested, they will eventually comment, they will eventually share, or they will get in touch with you with opportunities. And it is not a sprint, it is a marathon game. So I spent around two years in LinkedIn to be here right now with you, with thousands of followers, with some dozen of students. It's not it's not a game to everyone, because if it was for everyone, everyone would be with job, okay? So this is it is tough, but I believe that is rewarding. Let me see what time is it, because I received a message here about my meeting with my mentee. Okay, we still have at least 20 minutes. So it was one issue that I talked with Hasid. Okay, guys? And to finish this live session today, it's my plan to share with you my diary. And in my diary is the daily activities that I have as a chemical process engineer, at least from Monday to Friday. But this week, the 2 weeks, I am with extra work, and I working a lot. I getting from working until 11 p.m. So my time is very, very short these 2 weeks. But I believe that the next week I will have more time to share free content with you. So the last subject for today is about pumps, and I talked to a mentee from South Africa. It was I'm not so good with names, guys. Sorry. To Cello, and it was my second meeting with Cello, and he is a chemical engineer working with operations, and we discussed a little bit about pumps that he has in his facility. So what I have to share with you in general terms when we are talking about pumps. We have the design phase of the pump, and any project there are many phases in a project. We have the conceptual design, we have the basic engineering, we have the detail engineering, just to talk about the project phase or the design phase. And when we are in the design, in the conceptual design of a project, we have few information, and when we proceed in the working process, we have more information, and we can improve the quality of your work. Okay, so for the conceptual design, what is necessary to know is the pressure, delivery pressure at the discharge of the pump. We need to know what is the suction pressure, and we need to have the flow, and what is the fluid that we are pumping. With that, we have the head, and with the head, the flow, and some properties of the fluid, you are able to get a quotation and verify and receive from the supplier the curves of the pump that they are proposing. And in the curves, you will look for the pump that has the best efficiency, but just remind you that a curve of the pump is something like this. It's a curve from the top to the bottom, and you should select a pump that is not too close to the right side or to the left side, my left side, because you are going near to the shoot-off conditions, and you should not look or choose a pump that is too close to the flow axis, because this way you are far away from the best efficiency of the pump. And the issue that he was having in his facility is that when he operates the pump for too many times or for too long, the fluid gets hot, and because of that the pump shuts down. And he verified also that the impellers was damaged. So a way to starting verifying what is happening in the operations is get the pump curve of the pump that was installed, and verify if, according to the operation conditions, if you are too close to the shoot-off conditions. Because when you are centrifugal pump especially, you have a minimum flow recommended by the customer, by the supplier, because if you get too close to shutdown conditions, there are some kind of return flow inside the pump, and we are far from the best point efficiency, and when you decrease the efficiency, you add more heat to the fluids. So verifying that, you have the first clue to evaluate if the pump is in the correct size or not. And about the impellers, it could be some kind related with cavitation. So you must verify from the storage tank if you have some kind of storage, and to the pump side, to the pump suction, if the strainer, it's common to have a DPI in the strainer to verify if the pressure drop in the strainer increases. It means that the pressure available in the suction of the pump, of your pump, decreases. And if it decreases, it can lead to the cavitation conditions. So every time that you have a strainer at the suction of the pump, it's very, very important to be aware of the strainer. Okay, guys, to not have too much pressure drop on that. And the maximum pressure drop that you can have in the strainer will depend on the available NPSH that you have in your system. And remember, if we are talking about a vessel, we will consider as the minimum pressure, the minimum NPSH available, or the design NPSH available will be the minimal level of operation for your vessel. Remember that. Don't use the normal, don't use the maximum, use the minimum operation level of your vessel to guarantee that you comply with the NPSH requirements of your pump supplier. So based on that, if we evaluate that the pump size is bigger than it should be for the process, what you can do, and it is something that you should do when you are doing the design and the quotation of the pump. You can change, depending on the equipment that you bought, you can change the impeller size. And the customers, if we are talking about standard pumps, as we have for control valves, for the same casing, for the same pump casing, they design different sizes of impellers to comply with different requirements of flow and head. And when we are doing design and ask for quotation, always ask for the supplier to inform the design conditions for the curve for the design conditions, but also the available impellers for that kind of pump. So in this case, instead of having only one curve to analyze, you will have two. One for, of course, that depends on the supply. We have one with a lower, a smaller impeller, and you have another one with a higher impeller, or a bigger impeller. And why that is important? I am working in a project that we added a new equipment to the project, to the process, and the pressure drop increased. And my cooling water pump is already installed in the field. So, but I verified in the pump curve that it is possible to substitute or to shift the impeller in order to get the same flow, but with a higher head. And with that, instead of changing or instead of buying a totally new pump that is around to 20,000 reais here in Brazil, but just to give you some kind of order of differences, I will expend only 500 reais. So from 20,000 to 500 is a very big difference. So you can how can I say this? You can predict this kind of situation in the design, so you should select the pump according to this kind of knowledge. Okay, guys? And this is things that usually we learn only when we are in the field, when we are working, but I am here with you to share a little bit of my experience, and every time that I have new questions, it will help me to bring to you more knowledge. Okay, so guys, this is it. I have a meeting to Miguel Grados from Peru in some minutes, and it was very nice to be here with you. I have a goal to reach 100,000 chemical process engineers in my YouTube channel. So if for any reason this video helped you to improve your skills in chemical process engineering plant design, I invite you to help me to achieve that by liking, commenting, sharing with other people in order that I can achieve this goal. Okay, guys? So this is it. I hope you like it, and I'll see you soon in the next video. And about the mentoring program, I will not talk about this today. In the correct time, I will return with more news about that. Okay, Asad? So, bye-bye, guys.